Now let me walk you through how I built out this decision tree. The first thing we should do is go grab our dataset with an input data tool. I'm going to grab the employees underscore transportation data.yxdb. After bringing in this dataset, the first thing that I want to do is bring in a field summary tool to check the health of our data. What I want to see is first, are there any null records within our dataset? And from looking at the green ticker bars below each of the different fields within this interactive browse of the field summary tool, it looks that 100% of each of the fields are valid, meaning that there are no null values within our dataset. The other thing that I notice is that all of our fields seem evenly distributed and there's no skewed data. So for example, there seems to be a normal distribution of the age category. The drive distance miles is pretty normal besides for only a few number of records of people driving between 10 and 12 miles to work. And as well, our categorical variables has only 2 or 3 different categories within them. And this all seems very logical and our data seems pretty healthy. So I'm happy with the field summary tool's results. So what I'm going to do is I'm going to deselect this tool. And what I'm going to do is I'm going to create different samples of our data set, 70% in the estimation sample and 30% in the validation sample. As we can see, we have about 70% of our data in the estimation sample with almost 2,700 number of records over there, with only 1,100 in the validation sample and nothing in the holdout sample. So now what I'm going to do is I'm going to go straight to our decision tree tool. First thing I'm going to do is I'm going to name the model. So DT for decision tree underscore, and I'm going to say transportation, since that's what we're trying to predict. Then our target variable is going to be that mode of transportation. And then my different predictor variables is I'm going to choose the gender, age, marital status, and drive distance in miles. Since we can't choose the mode, since that's what we're trying to predict. And the first field, the employee ID, is simply an ID field. I'm now going to bring in a browse tool after the interactive result and run this model. What I'm able to see, first of all, is that the drive distance in mile and the age are the only 2 variables that are actually important at all in this model. Therefore, the other variables that we put into the model were not used at all to build this decision tree. The next thing I see is that we have many different splits within this data set to go to our 3 different possible terminal nodes: public transportation, bike, and car. But instead of going to interpret these results, what I'm going to do is go over to our confusion matrix and view that 96% of our different variables were classified correctly. This is very strong, but again, this is the estimation sample against the data that was used to build that model. So we need to definitely go and validate our model versus an independent data set. But I'm able to see that bikes were predicted correctly 100% of the time. Cars were as well, but public transportation was quite lower at 86%. So overall, this looks very promising so far. But as we know, decision trees have a high likelihood to possibly overfit a data set. So what we should do is we should really test this model out against a validation data set to determine how strong this model actually is.